Now electric current in conductors. See, we discussed this thing when the charge flow through the any cross section of the conductor in given time interval, then the current is constituted. We know this thing. There are large number of free electrons in the conductors in metals, and all these electrons are executing thermal motions. But the motion of the electrons, that is randomized one. So when random motion of electrons is there, and if any type of electric field is not present in the conductor, then if we think about any cross section of the conductor, then through this particular cross section, the net amount of charge flowing in a given time interval, that comes to zero. Because when the motion of the electrons, that is random motion, then in that particular case, if as per example we take suppose n number of electrons are flowing through this cross section in given time t from right side to left side, then the same n number of electrons will flow from this cross section on left to right side. So when we calculate the net amount of charge flowing through the cross section, then it will come to zero. So the current will not be constituted in it. Now, if we want to constitute the current here, then there should be some net flow of charge through any cross section of the conductor. Clear to all of you up to this one? Now, suppose we give some electric field to the conductor. How? See here in text, one simple example is given to you. As you see in this second figure, suppose we take two non-conducting plates having area exactly equal to cross-sectional area of the conductor. Then on one plate, we deposit positive charge. On another plate, we deposit negative charge. It implies that we can say one plate is made positively charged, another plate is made negatively charged. Now, attach both these plates to the ends of the conductor as shown in the figure. Now, one end of the conductor, that is, we can say positively charged, because there the positively charged plate is attached, and another end of the conductor that we can say is negatively charged, because there negatively charged plate is attached. So inside the conductor, from positive to negative, the electric field will be developed. Now we know this thing. When any charge is in the electric field, then force acts on it, that is Q into E. So here electrons will experience the force in the opposite direction of electric field. So some net flow of electrons will start through any cross section of the conductor in the opposite direction of electric field. But when this electrons reaches to the positive plate, it will neutralize the positive charges. So when the plate is completely neutralized, then after the current becomes zero. So here momentarily for some time interval, the current will be constituted. Clear to all of you? Now, for small time interval here, the current is constituted. But suppose we want to produce the steady current, then what we have to do? Then we have to make the provision of constant electric field inside the conductor. And now for that, except attaching the charged disk, connect the battery or cell across two ends of the conductor. Okay, so here now steady electric field will be produced in this conductor. Now electrons will flow towards the positive terminal of the battery, and negative terminal of the battery will release the electrons, and here the continuous flow of net charge through any cross section of the conductor will be obtained, and resultantly you will get the continuous current through the conductor rather than the current for a short time interval. Clear to all of you?